everyone, and welcome to College Algebra. Today we will be discussing section 4.3, which talks about properties of logarithms. So the first property that we will be looking at is the product rule. So the product rule. And what is the product rule? It says log to the base b of m multiplied by n is equal to the log to the base b of m plus log to the base b of n, where both m, n, and b are positive real numbers. Positive real numbers, and b is not equal to 1. All right, so we can use an example to illustrate this. So this will be our first example. So example 1 is A is log to the base of 6 of 7 times 11 is equal to the log to the base 6 of 7 plus log to the base 6 of 11, and the b is log of 100x, which means the default base is 10, but we don't write, so this is equal to the log of 100 plus log of x, and log of 100 is 2, so this is 2 plus log of x. So the next rule we want to look at is the quotient rule. The quotient rule. The quotient rule is log to the base b of m divided by n is equal to the log the base b of m minus log to the base b of n, where the m, n are all positive numbers and b is not equal to 1. So let's use example 2 to review this formula. So example 2. So the first example, log to the base 8 of 23 divided by x is equal to the log to the base 8 of 23 minus log to the base 8 of x, and b, log b is the natural log of exponent 5 divided by 11. This is equal to the natural log of exponent 5 plus the natural log of 11, and by a property minus 11, not plus 11. And by the properties of logs, log exponent 5, let me write this one. Log exponent 5 is equal to 5 log of e minus log of 11. And by the properties of logs, again, log of e is equal to 1. So this equals to 5 minus natural log of 11. All right, so let's look at the next rule, which is the power rule. So what does the power rule say? So the power rule says log to the base b of m power p is equal to p log to the base b of m. So whenever there is a power, we can bring it in front of the log. So example 3, let's look at some examples on this. Example 3a is log to the base 6 of 3 power 9 is equal to 9 log to the base 6 of 3. Natural log of cubic roots of x. Cubic root of x is the same as x power 3, 1/3. So this is equal to the natural log of x power 1/3, which is equal to 1/3 of x. And c is log of x plus 4 squared is equal to 2 log of x plus 4. An example, let's look at another example, example 4a. Let's look at that on the next page. Example 4a says log to the base b, log to the base b log to the base b of x power 4 cubic root of y. This equals to, so applying the properties of logs, applying the power rule first, this will be equal to the log of x power 4, and cubic root of y is the same as y power 1/3. And so from here we can apply the addition property, which gives us log to the base b of x power 4 plus log to the base b of y power 1/3. And using the power rule, this becomes 4 log to the log base bx plus 1/3 log to the base b of y. Let's look at another example 4a. This is example 4a. Let's look at another example 4b. And it says, use the properties of use logarithmic properties use logarithmic properties to explain the expression as much as possible. And so this is log to the base 5 of square root of x divided by 25y cubed. All right, so this is equal to the log to the base 5 of square root of x is the same as x power 1/2 divided by 25y cubed. And using the quotient rule, this is equal to the log of x power log to the base 5 of x power 1/2 minus log to the base 5 of 25 y cubed. And this is equal to, using the power rule, log base 5 x power 1/2 is equal to 1/2 log of 5x and minus, into parentheses, we use the addition rule on the second term. So minus log 5 of 25 plus log 5 of y cubed. And this equals to this equals to this equals to 1/2 log base 5 of x minus log base 5 of 25 is the same as 5 squared minus 3 log of y. And this equals to 1/2 log of base 5x minus log base 5 of 5 squared is 2, so minus 2 minus 3 log of base 5y. So this is how far we're able to expand this expression. So as much as we can use properties to expand logarithms, we can also use the similar properties to condense them. So that means like working backwards. So that next thing we want to look at is properties of properties for condensing logarithmic expressions. Properties for condensing logarithmic expressions. So one, the first property is log to the base b of m plus log to the base b of n is equal to the log to the base b of m times n, which is the product rule that we talked about. So this is working backwards. 2 log to the base b of m minus log to the base b of n is equal to the log to the base b m divided by n. And this was a quotient rule. And 3 p log to the base b of m is equal to the log base b of m power p. And this is the power rule. All right, so let's see some examples. So example 5, which is based on condensing logarithmic function. So it says write as a single logarithm. Write as a single logarithm. A is log to the base log of 25 plus log 4. And this is equal to the log of, using the product rule, this becomes the log of 25 times 4, which is equal to the log of 100, and the log of 100 is 2. B, log of 7x plus 6 minus log of x. So minus means if we are condensing it, we use the quotient rule. So this is the log of 7x plus 6 divided by x times both of them. This is like this. Let's look at another example. So this will be example 6a. And it says write as a single logarithm. And it says 2 times the natural log of x plus 1/3 x plus 5 is equal to the natural log of x squared plus log of x plus 5. So first, using the power rule, this will become using the power rule. Let me write this way first. All right, so using the power rule, what's on the inside would first become 2 log of x plus 5 power 1/3. And using the power rule, this becomes 2 log of x plus 2 2 log of, I think I did not write the question well. I did not write the question well. Yeah, I think I made a mistake in the question, so let me clean that up. I think that this is supposed to be, let me write the question properly. So this is supposed to be 2 log of x plus 1/3 x plus 5. So this is equal to 2 log of x, 2 log of x plus, using the power rule, this is x plus 5 power 1/3 and bracket close. And so this is 2 log x plus 2 log x plus 5 power 1/3. And so this is log of x squared, and this is also the log of x plus 5 power 1/3 times 2, so power 2/3. And so this becomes the log of x squared and and let me write this power 2/3 as, let me write it, first of all, let me write it this way. That will make using cubic roots later. So this is power 1/3. So this is, okay, so this is power, let me write it as power 1/3 power 2. Okay, so this is plus. So this is log of x squared plus so this is the log of this is the same as the log of x plus 5 squared power 1/3 is the same. 2 times 1/3 is the same as 1/3 times 2. So we can write this way. So from here, I'll get log of x squared plus log of cubic root of x plus 5 squared. Okay, so here I can condense both to be log of x squared and the cubic root of x plus 5 all squared. So I can write it this way. All right, so the next example that the next topic we'd like to discuss is the change of base property. The change of base property. All right, so the change of base property says log to the base b of m is the same as log to the base a, which is a log to the base a, log to the base a of m divided by log to the base a of b. And for any positive real number, m and a and b are bases. So this is for any positive number m and bases a and b. Okay. And also for common logarithms, common logarithms means it's the base 10, which we don't write. So for common logarithms, we have log to the base b of m is equal to the log of m divided by the log of b. And for natural logarithms, we have log to the base b of m is equal to the log of natural log of to the natural log of m divided by the natural log of b. So let's see some examples to illustrate these. So example, this would be our example 7. And it says use common logarithms to evaluate common logarithms to evaluate log to the base 7 of 2506. All right, so log to the base 7 of 2506 is equal to the log of, using common logarithms, log of 2506 divided by log of 7. And here we can use our calculator to find the numerator and the denominator. And if we do so and we divide, we'll see that this will be approximately 4.02. it should be about 4.02. Let's look at another example. This is example 8. And it's the same, use natural logarithms. It says use natural logarithms to evaluate log to the base 7 of 2506. So log to the base 7 of 2506 is equal to the natural log of 2506 divided by the natural log of 7, which is approximately also equal to 4.02. So using common logs or natural logs, we get the same thing. All right, so section 4.3 is a short one, and so this would be the end of 4.3. And so we shall discuss the next section shortly, which is 4.4 shortly. All right, so thank you and bye-bye. I'll see you in the next video.